Alright, so we have a question on the board. Let's try and solve it. The question says the angles of elevation of a point C from A and B are 45 degrees and 60 degrees respectively. That means that A is looking at the object upstairs with an angle of 45 degrees and B is looking at the object at 60 degrees. So let's assume that this is the solution. This is the point C. So let's say one of them is standing here, and then the next person is standing somewhere here. This is the horizontal ground. And then this is the distance between the object and the horizontal ground. This distance is the same as the height of the object C. This is forming an angle of 90 degrees here. Now, you don't just stand up and put A here and B here because A came first and B came second. No. Angle of elevation is something that is really practical. You can exhibit it. So now, if A is looking at the object at angle of 45 degrees, what that means in real terms is that A is farther from the object than B is, because B is looking at the angle at what? 60 degrees. So angle elevation, that is when you are looking something upstairs. You have to raise your eye. So the angle at which you raise your eye to look at the object upstairs is what you call angle of elevation. Now, when you are closer to the object, your angle of elevation is greater than when you are farther from the object. That is why sometimes when you are looking at objects from very far, they look a little bit tiny. And it is so, not because necessarily you have a problem with your eyes, but because your angle of elevation, that's the angle at which you are raising your eye to see the object, is what? Smaller. So since 45 degrees is smaller than 60 degrees, it means that 45 degrees, or that is the what? The person A is farther from the object. So we have here B, and then here what? A. So this is 45 degrees. This is what? 60 degrees. I hope we are okay. So now, they said the distance between them is what? 10 meters. If the distance between A and B is 10 meters, and the point C is above the ground, that's what this is the point, this is the ground. Find the distance between what? The point C and the horizontal ground. So now, let's assume that this place is D. So let's pick this triangle like this. This smaller rectangle triangle here. This one. So we say from triangle CDB. CDB. So this is CDB. This is C, this is D, and this is what? B. This is H. Now, we don't know the distance between D and B. That is the distance between B and the foot of the object we are looking at. So let's assume the distance is what? X. So this place becomes what? X. Our angle is what? 60 degrees. So I'm looking for the height here. Why am I looking for the height? If you watch carefully, A is looking at the object here, and B is standing here looking at the same object. So there's something that is common between A and B, and that thing is what? The height at which both of them are seeing the object is the same. So let's assume this is a building. If somebody is standing here and the person is looking at the object here, at the top of the building, another person is standing here and looking at the top of the building, the fact that there's a distance between them doesn't change the height of the building. The height of the building remains the same. So as it remains the same, it means that both of them are seeing the building at the same height. The only difference is that they are standing at what? Distance apart. So if I know the height at which B saw this object here, and then I know the height at which A also saw the object. Since the height of the object is the same, I'll bring their two heights together, and then I can get the height of the distance between these places. So now I'm looking for here. I have this. So I say what? Tan 60 degrees is equal to opposite. That's what? H over what? X. Alright. So this implies that if this is over 1, my H is equal to X times 60. I cross multiply. So H times 1 is H, and then this times that is this. Now, this gives me H is equal to what? Tan 60 is root 3. So that is X root 3 meters. So the height at which B saw the object is what? X root 3 meters. Now let's look at the height at which A also saw the same object. Now this is the height at which A is seeing the object. Here like this. So this is the height. So you can see that the same height that A is also looking. So let's draw that triangle. That is triangle CDA. So from triangle CDA, this is a triangle CDA. Okay, so this is H. Now, the distance from A to the foot of the object we are looking at is this plus this. So that is X plus 10 meters. And then the angle is looking at is what? 45 degrees. So I'm looking for this H. So I'm looking for this, I have that. So tan 45 is equal to opposite, which is what? H over adjacent X plus 10. Again, if I cross multiply. Now this tan 45 is 1. Tan 45 is 1, which means that I have what? 1 over 1 is equal to H over X plus 10. If you cross multiply, since we are working with our object, let me clean it. So this implies that H is equal to what? X plus 10, everything here, meters. So this is the height at which, let me say this is equation 1, and then this is what? Equation 2. So A is looking at the object C at this height, and B saw the object at this what height. But like I said, the building is the same height, which means that the height at which A is seen is the same as B is seen. So this implies that the height of B, which is what? X root 3, is equal to the height of A, which is X plus 10. Okay, so collect like terms, we have X root 3 minus X. This is equal to 10. This gives us X into bracket root of 3 minus 1 is equal to what? 10. Okay, so my marker is getting lighter. So from here, I'm looking for X. So I'll divide through by what? X into root 3 minus 1 all over what? Root 3 minus 1. This is equal to 10 over root 3 minus 1. Now, let me clean this here. Okay, so from here, my X will be equal to 10 divided by root 3 minus 1 will give us 13.660 meters. You can test it with your calculator. Alright. So now, we know that the distance between the person B and the foot of the building is what? 13.66 meters. So this is how the diagram works. So here was X. So here is what? 13.66 meters. And then here is what? 10. And then here is what? H. Now, what is the connection between B and then the foot of what? The object. And then the height of the object. The connection is that what? H, which is the height of the object, is equal to what? This X plus what? Plus 10. So this implies that height, which is H, is equal to what? 13.660 plus 10. That gives us what? 23.660, approximately 24 meters. So you see, therefore, the distance between C and the horizontal is equal to what? 24 meters approximately. I hope you understand. Alright, so please like and share, and don't forget to follow my page so that anytime I drop goodies like this, you can be able to see it. I concentrating on questions like this because WAEC has changed the face of the way they ask their questions. These days, most of their questions are very practical. If you check the paper they wrote this year and that of last year, that's WAEC mathematics. More than 80% of the questions are practical questions. And they need you to what? Because they want students to start thinking critically. Problem-solving mind or brains, they want students or children to have these days. So they are shifted from the traditional way of asking questions where you are just be finding S and Y. These days, the questions they are asking, you need to think very well before you can be able to answer it. That's why I'm bringing you this type of questions. So please, do well and follow me so that we see more of this.